Hello, everyone. Further to our previous lecture number 3, excavation in ordinary soils, method of statement. Here is the lecture number 4. We will analyze the price analysis of the item. The audience must watch lecture number 3 before this one. After lessons in lecture 1, 2, and 3, we can say that the pricing engineer is ready to start pricing after getting all relevant data. A clear understanding of the contract and all tender documents. A perfect familiarity with the inspection report. Having a list of all supplies price rates. Having a list of all equipment rental price rate. Actual awareness of equipment implementation rates. Final awareness of official tax or deductions and the agreed indirect cost and profit percentage. Here is the Excel sheet. BEQ item total quantity is 200,000 meter cubic. The activity or summary of the item is number 1, supply material, number 2, excavation, number 3, grading, number 4, transportation internally for the valid material to the backfilling area, and number 5, transportation externally for the invalid material to the public dump. Let us start with the item supplies. Do we have supplies in this item? This is the question. Yes, we have water. Water only, without transportation. Unit of water supply is meter cubic. We have got more than water source detected from the project site inspection. The best average price was 30 Egyptian pound per meter cubic without transportation. We do not have a tax here. Since we consider that the waste and evaporation of water is 10%, it means that the waste factor is 1.1, which means that the partial cost of water only equal price of water from the source multiply the factor of waste and evaporation. The partial cost is 33 Egyptian pound. Let's go to the excavation cost. We found out that 1 hour dozer D9 rent cost 1,500 Egyptian pound per hour, which means that daily rent equal 1,500 Egyptian pound multiply 8 hours daily work equal 12,000 Egyptian pound. 1,500 in 8 hour multiply 1,500 equal 12,000 daily rent. Amount or rate. The implementation rate of such a dozer ranges from 1,000 to 1,500 cubic meter excavation, depending on mechanical condition of the equipment, nature of soil to be excavated, operator experience, and skill. Therefore, and from empirical and previous experiences, we will consider the average implementation rate of dozer D9 or equivalent will be 1,200 cubic meter of excavation in ordinary soil. The final cost for excavation in this case will be 10 Egyptian pound. Daily rent 12,000 over excavation rate will equal 10 Egyptian pound. The yellow highlight here in our style of calculation means it is a final cost of the sub items. Forget about now the height of cut. We will need it later. After reaching approximately the bottom of subgrade PSG by dozer, a grader and compactor are needed for grading or final level adjustment. If the daily rent of grader is 4,000 Egyptian pound and implementation rate in 8 hours is 2,000 square meter. Be careful, our item in cubic meter. It means that 4,000 Egyptian pound over the implementation rate, it means or it gives the cost of 1 meter square grading. 4,000 Egyptian pound over implementation rate in meter square. It means that each meter square grading is cost 2 Egyptian pound. The same way for the compactor. If the daily rent of the compactor is 2,000 Egyptian pounds, and of course the same amount of implementation rate, 2,000 square meter, it means that the cost of compactor is 1 Egyptian pound for each meter square. For your information, if the average implementation rate of grader is 2,000 square meter in a dry condition of the soil, this rate will be increased by 50% if the material layer is already pre-mixed with water, since we have saved the grader mixing time. We need also to know the cost of water transportation by tanker. If the daily rent of the tanker carrying water from its source and the capacity of this tanker was 10 meter cubic, and from the inspection study for the distance between the sources and the site work, the engineers estimate that the number of trips for the tankers can be from, for example, 4 to 6, which means that the average trip is 5. Here, if we divide 2,000 Egyptian pound, the daily rent of the tanker, over the trips, it means that each trip costs 400 Egyptian pounds. It means that each 10 cubic meter of water transportation costs 4 400 Egyptian pounds. But we are interested in the cost of 1 meter cubic of water. It means that this 400 will be divided over the capacity of the tanker, which means that 1 meter cubic of water transportation costs 40 Egyptian pounds. Total partial cost of water equals 73 Egyptian pounds. We have here cost of water 33 Egyptian pound. This is the price of 1 meter cubic of water only, and its transportation. It means that 33 Egyptian pound water price plus its transportation for 1 meter cubic. It means that the partial cost of water 73 water price plus transportation. Let us calculate the cost of water content in the subgrade layer. But we need first to ask a question. Do we have a layer here in this excavation item? In fact, we don't. But a layer will be automatically generated when the grader starts to scarify the bottom of subgrade surface for 15 centimeter depth, or according to the specification. This procedure is being done mainly to ensure water spray penetration to the soil to have a well-compacted homogeneous subgrade layer with a proper surface. Let us calculate the cost of water content in a material mix. Water content is calculated as a percentage of weight, not as the majority thinks it is in volume. The evidence for this is the difference in the sand cone sample weight before and after drying it in the oven. We all know that density equals weight over volume. Consequently, weight will equal density multiply volume. The average optimum moisture content is about 7% in weight. Since we are in the studying stage, there is no time to measure the density of the material. We will consider it as a sand density 1.6 ton per meter cubic. The amount of water content in 15 centimeter layer equal volume of layer by compaction factor. It can be 15% or 10%, or according to the nature of the material you have in your work. Okay, amount of water content equal unit volume of layer multiply compaction factor multiply density multiply moisture content. Amount of water content in this case almost 0.02 meter cubic. Almost. Or you can say almost 20 liter of water. The cost of water content equal amount of water in the layer multiply the total partial cost of water. 0.02 almost meter cubic of water multiply 73 Egyptian pound, which is previously calculated for water and its transportation. It means that, or the result is 1.14 Egyptian pound for water cost. Finally, grading cost equal grader cost, if you remember, 2 Egyptian pounds, plus compactor cost, plus water content cost, equal 4.41. Let's check. Equal 2 plus 1 plus 1.41. We have here the total grading cost is 4.41. Another issue should be added to a meter square cost. This all cost is in meter square. And be careful, remember that our item is in cubic meter. This another issue is lab test. We are taking the samples each 20,000 2,000 square meter. The one test costs 1,500. It means that one test costs 0.75 Egyptian pounds. Cost of one test over or each 2,000 square meter equal 0.75. Total grading cost will equal grading cost plus cost of lab test 4.41 plus 0.75 each meter square. Let's check. Plus 0.75. It means that total grading cost, including tests for each meter square, equal 5.16. So the grading cost in meter square equal 5.16 Egyptian pound. If we look for a moment at the grading cost, grader, compactor, water, and even lab test, we will discover that this procedure is done mainly in a square meter, but the item is in the cubic meter. In this case, we will have to load it on a cubic meter. Look carefully at the image. Assuming that the cubic meter of cut is just a uniform cube. square base 1 meter by 1 meter and 1 meter height. The grading cost is still the same in meter square, whatever the height of the cube. Here we have a cube, base 1 meter by 1 meter, but the height here is 2 meter, right? The same square meter cost of grading. If the height of the cube is 0.5 meter, the result is the same, 5.16 Egyptian pound. Whatever the height is 1 meter, 2 meter, or 0.5 meter. This is in meter square. But if we load the square meter grading cost on 2 meter cube height, the grading cost in cubic meter will be 5.16 over 2. It will be 2.58. So the grading costs in this case per meter cubic will be 2.58 Egyptian pound. The same way, the grading cost in cubic meter will be 5.16 over 0.5 meter height. The cost of grading in meter cubic in this case will be 10.32 Egyptian pound. But when the height of the cube is 1 meter, the cost of square meter will be the same in cubic meter. We are going to divide 5.16 Egyptian pound over the height of 1 meter. It will be the same. Our example here, consider the height is in 1 meter, if you remember. The conclusion here, we have to be careful in grading cost calculation, especially when the height of cut is less than 1 meter in this case. Somebody can ask, from where can I get the height of cut? It's amazing question. The tender document in such a kind of project always include the horizontal and vertical alignment design, whether a hard copy or soft, from which we can get the approximate average height of cut, bearing in mind it is measured from the bottom of subgrade, we call it Ferma in Egypt, to the surface of the natural ground. Let's start calculate the internal and external transport. We will move or transport the valid product of cut to the backfilling area, as well as the invalid material to the public dump. But Nobody knows the percentage of valid to invalid material. Since we do not have a fortune teller to tell us, we will consider such a percentage equal 50 to 50%. In other words, each cubic meter will be divided into two. 1/2 meter cubic to be moved to the backfilling area and the other half to be moved to the public dump. This is one of the risks in the price analysis. After bargaining with the transportation subcontractor, the internal transport rate of 1 meter cubic for average 3 kilometer distance will be 12 Egyptian pound, and the external to the public dump for average 10 kilometer will be 18 Egyptian pound. The internal transport, where the rate of 1 cubic meter is 12 Egyptian pound to move the valid material to the backfilling area. The waste and compaction percentage will be 15%, which means that the factor will be 1.15. The actual cost will be 12 by 1.15 equal 13.8. Let's check. Equal 12 multiply 1.15, 13.8 Egyptian pound. Do not forget that we don't know the percentage of valid to invalid materials, as previously said. We will consider it as 50%. It means that 13.8 multiply 50%, the cost of internal transportation to the backfilling area will be 6.9. Let's check. 13.8 multiply 50%. This is the final cost of internal transport for 3 kilometers to the backfilling area. The same way in the external transport to the public dump for 10 kilometers. 18 Egyptian pound multiply the factor of compaction 1.2 equal 21.6. Let's check. 18 Egyptian pound for each 1 meter cubic transport multiply the compaction and waste factor will give 21.6. Again, the 50%, it means that 21.6 multiply 50% will equal 10.8. We notice here that the waste and the compaction percentage in the external transport is 20%, while in the internal one is 15. This is because the truck loading capacity externally is a little bit less than the internal, to avoid as much as possible any material spreading to the highway during driving. which can create violations or troubles with the traffic authority. Let's start to finalize the item total price. Here is the direct cost. Direct cost equal all the cost of sub items. Equal what? Those are costs plus, look here, grading costs plus, look here, internal transportation plus external transportation equal 32.86. This is direct cost, or sometimes they call it dry cost. The indirect cost is a 10% of direct cost equal 10% multiply direct cost. Total cost or all cost for direct and indirect will equal the sum of those number equal 32.86 plus 3.286 equal 36.146. This is the all cost, direct and indirect. We have here a profit. I proposed 5% profit. You can propose 10%. You can propose 20%, as you like. But we are trying as much as possible to increase our chance to award a tender competition. If the profit is 5%, it means that the profit will equal 5% multiply all cost. We have here 1.807. A cost and profit equal 37.95. Let's check. All costs, direct and indirect, plus the profit. Sorry. We have here cost and profit is 37.95. If we have a tax or deduction 15%, it means that we will add it to the cost and profit. 15% of official deduction or taxes equal 15% multiply 37 equal 5.693. The final price in this case will equal 43.65. Let's check. Cost and profit plus deduction. This is the final price, 43.65. If you want to know the PQ item total price, we will multiply the final price multiply the quantity in BOQ 200,000. Here you have a full information about the item, unit price and POQ item total price. We have here a little mistake. Most common mistake being done by most of the price analysts. If you can get it, please inform me in the comment. I'm sure that nobody would give a damn. Nobody will write any comment as usual, but it will be necessary to find here the little mistake. Thank you for listening. Thank you for being my audience. Have a nice day, and we will meet again.